A Roman bishop sits by the window of his home on the North African coast, squinting at the sun as it bathes the Mediterranean in golden light. Meet Augustine of Hippo, theologian, philosopher, saint, and probably one of the earliest overthinkers in history. He stares at the waves, thinking if only time would pause, or even rewind imagine the chaos. He imagines the sun rising backward, waves stacking themselves like Lego bricks before retreating back into the sea. Unsettling, absolutely, but entertaining to picture. If time marched forward relentlessly, that's even scarier. Waves would crash endlessly. The town would crumble. Homes reduced to heaps of sand. Augustine's quill might as well scribble in vain as the world dissolves into dust. Stars wink out one by one. What is time? He whispers. Spoiler, he's about to get an answer, but it will take centuries. Fast forward about 1,500 years. England, early 19th century. People in Manchester are about to experience their very first time jump. Before railways, clocks were set by local sundials, and time could differ by 30 minutes from town to town. Imagine going to London and missing your train by half an hour. Chaos, enter Industrial Revolution logic. We need standard time, people. In January 1846, Manchester jumps forward 13 minutes to match Greenwich time. Everyone collectively time traveled without leaving their homes. The sun, completely unimpressed. Meanwhile, engineers noticed steam engines were running the world, but nobody really understood why. Enter Sadi Carnot, a French physicist with a knack for stating the obvious in life-changing ways. Heat flows from hot to cold. Fire warms rooms. Ice melts in the sun. Planets cool in space heat. Never, ever goes backward. This simple observation laid the foundation for the second law of thermodynamics. In short, order turns to chaos every time. Entropy, baby. A functioning locomotive, low entropy. A scrapyard heap of the same parts, high entropy. Leave the engine alone long enough, and it will fall apart. Coal burns, heat disperses, and energy scatters. Order becomes chaos. That, my friends, is why your computer crashes if you don't save its all entropy's fault. And yes, it's also why time moves forward. Arthur Eddington, early 20th century, strolled home from Cambridge's observatory with his head full of stars. A stern woman handed him a feather don't. Ask why and he politely sidestepped her, adding it to his mantelpiece collection. Quaker, pacifist. Society called him coward. Physics called him legend. He popularized the arrow of time. Everything moves from order to disorder. Cause comes before effect. Time goes forward. You can't fight it. Science fiction loves backward time travel. Imagine waves uncrashing or wreckage assembling itself like a self-building Lego set. Impossible, yup, violates the arrow of time. Double, yup. Even Einstein's relativity says you can't beat light speed. Unless you want to experience a cosmic version of Oops, I'm my own grandparent. And Stephen Hawking tested it in style. He held a party for time travelers, and nobody came. Guess that's one party no one will forget or attend. Going forward in time, that's easy. We do it every second. Want to speed it up? Hang out near a black hole. A single second for you could equal 17 Earth hours for your friends. Talk about extreme procrastination. Ludwig Boltzmann imagined the universe like an infinite billiard table, particles colliding like balls. Disorder is much more likely than order. He argued that entropy makes the arrow of time statistically necessary. He also moved around a lot from Austria to Germany, with moods as unpredictable as the particles he studied. Tragically, the world didn't appreciate him in life, and he ended his story too soon. Black holes are the universe's ultimate mess makers. So much mass crammed into tiny space that their entropy blows everything else out of the water. The Milky Way's central black hole alone has more entropy than the entire universe after the Big Bang. As they gobble matter, entropy rises, time moves forward, and the cosmos marches relentlessly toward chaos. Eventually, trillions of years from now, black holes evaporate, energy spreads evenly, and the universe reaches maximum entropy. Nothing new can happen. Time doesn't matter. The universe becomes a silent, featureless void. But even here, quantum fluctuations might randomly create pockets of order like spontaneous mini-universes or Boltzmann brains. These hypothetical brains could pop into existence with thoughts, memories, and no body. Imagine that. Brains floating in empty space, thinking, am I real? Creepy, right? Physicists are still hunting for answers. A contracting universe, string theory collisions, or something entirely unexpected. Augustine pondered the nature of time. Eddington explained its arrow. Boltzmann warned of random brains, hawking through parties. And yet the big questions remain. Time evades definition, flows inexorably forward, and keeps all of us, mortal humans and cosmic observers alike, along for the ride. So, from Augustine staring at Mediterranean waves to black holes swallowing galaxies, from trains in Manchester to Boltzmann's cosmic billiards, one thing is certain: time moves forward. Chaos increases, and the universe never, ever stops. Augustine might have been overthinking it, but he was right. Time is mysterious, relentless, and occasionally hilarious when you imagine humans jumping 13 minutes forward in 1846. And maybe that's the fun of it. We live in a universe we can barely understand, where even the most brilliant minds are just trying to keep up with the arrow of time.